Okay, guys. So I was playing poker last night with some of my friends from Claremont. I know that might sound amazing to you that I actually have friends, but I do. And so I was thinking about probability and chances of things happening, and really hoping for certain things to occur. And they actually did. I did okay last night. But so here we have a deck of cards, and we have a dice, and we're looking at probability of events occurring. So I'm just going to show you this is sort of a normal deck of cards if you're played various card games, stuff like that. And so what we're going to do here is just take a card at random, show you that card. And so of course there's no way I could see that card because my head is above the screen, right? No chance. Anyway, so that's the card we're looking at. You guys got a good look? Okay, so put that there. Okay, and we put the deck of cards on top of that card. Okay, and so what we're gonna do now is we take our deck of cards and we take our bottom card and we put it on top of the deck, and then we put a card down, take the top card, put it on top of the deck, put that card down, and kind of repeat this a few times. We'll just do it 4 times there. Okay, so here we have 4 cards in front of us and then the remaining cards in the deck here. And so I'll put the big deck down there, and I'll just sort of kind of put these guys together here. And so your job now is to sort of figure out where that initial card is. Where would that card be there? Okay, so it could be in the big deck. Maybe you think it's in the big deck, so put the big deck over here. Or maybe you think it's in the smaller deck, and it's somewhere in there. So that's probably easier to look through the smaller deck here. So here we go. So is that your card there? Okay. So okay, so I'm thinking that's not your card. Okay, so let's put that card down, and then we'll flip that over. And then the question is that your card, or the card we showed you earlier on? Okay, so we'll put that one down, and then is either of these the cards you were looking at? No. Okay, so let's put those down. So it seems clear that maybe it's in this deck here, or maybe I hid it. Maybe I threw it over there somewhere, or up there, up there. Maybe it's in like my. It would be cool if it's in my mouth right now. It's not though. Okay, so here's our dice here. Okay, so we're gonna organize our cards here. Okay, so put them like that so you see them. No, I can't see them very well. Okay, so put them back like that. Okay, so we're just gonna roll a dice, and I'm just gonna take whatever number I see here. So I can't know if you see that, but that's a 4. It's a 4. So I'm going to say it's not the 4th card here. So 1, 2, 3, 4. So it's not that card. Okay. And then I roll the dice, and I get a 7. So 7 there. So 1, 2, 3, 4, 5. Oh, sorry, where we start 7. So wow, so 1, 2, 3, 4, 5, 6, 7. So it's not that card. And we'll roll. Let's just go for even odds here. And so we say 2. So 2 there, 2. So 1, 2. Okay, so there we go. So we're left with this final card here, and so it turns out that this card is actually the card we're looking at, right? So this is our card, I think. So I think, did I see it? I did. So there we go. So there we go. So it's cool. Okay. So these are when we talk about card games, stuff like that, games of chance. Now, a lot of times we can manipulate games by knowing how to control certain cards or how to maybe rig certain games. But what we're going to look at now is the probability of just picking a card at random and doing that. So if I was to take this deck of cards and just stick the queen somewhere in here, and then and do an honest shuffle, so no putting my pinky anywhere to mark something, and I just truly shuffle the deck here. So randomize the deck, and then let's say that we gave this to someone else to shuffle it and shuffle it and shuffle it, and it was truly randomized here. So let's sort of talk about today's thing here. So let's say we truly randomize this deck of cards, right? And I was to now in a fair way and reach in, and I just pulled out just by chance. That's close. But if this was the Queen of Hearts, what would that chance be? Would that be a good chance? Would that be a likely thing to occur or an unlikely thing to occur? And what if I did it many times? Like what if I said I'm going to try to do it 5 times in a row, and every time I do it, I'm going to pull out the Queen of Hearts. So would that be more likely to occur or less likely to occur than just doing it once? Or what about the question of, like, let's say I do it 5 times in a row. what's the chance of me getting it right once? That is, I pull one queen of hearts out of the deck and 5 goes. Is that a pretty likely thing to occur? And now playing card games may not be your thing, but if you think about, like, you guys are in grade 9 now, so you have another 3 years of high school, and maybe some of you going on to university and college. And many times teachers give you multiple choice tests. I mean, I've done that over many of the tests we've done online here. I don't believe multiple choice are always the best way to measure a student's understanding of math, but they're just one tool that people can use to get an approximate idea of what you know. So let's say, and that has happened on the test, let's say you leave a question blank, right? So you leave a question blank. Well, obviously you get 0 now for that question. So there's just no chance you're going to get any points if you don't choose something. So, but let's say you did choose something, but you really didn't know the answer. And I think sometimes that's what students do, is they just say, well, I don't know what it is, so I'm not going to bother. And I'm not sure why they think that way, because if you just took a stab at it, and obviously you would have a chance to get it right. And on a 4 answer stemmed multiple choice, I mean, you should know what your chance of getting that right is. Now, of course, if you left, let's say it was a 10 question test, okay, 10 multiple choice questions, and you left them all blank. You just didn't even bother. I don't care. Just left them blank. I'm going to hand it in. What do you think your chance would have, or what do you think you would have gotten on that test had you just guessed? You just took your pencil and you just chose 10 random questions. You just said, I'm just going to choose these 10 random questions or answers to the questions. Do you think you would have gotten 0? Like, do you think that's a likely thing to occur, that you would have gotten 0? Or do you think it's a likely thing to happen, you would get now 100% on that test, right? Because what might surprise you is that, let's say you knew nothing. What your teacher gave you you walked into your English class, and your teacher gave you a physics test there, and you'd never done physics before. You never heard of any of these questions before, and you just said, okay, I'm gonna do my best here, but you know nothing. Like, you know nothing about that subject. So if you didn't answer anything, you would get 0, which is reflective of what you know. You know nothing about that subject. But if you just tried it, do you think you would get 0? Like, do you think you would actually get 0 on a 10 question multiple choice test? You could, I guess that's possible. But what do you think the average mark you should get? Like, what do you think the average should be if you were to do that? Okay, so I think it might surprise you. And what might also surprise you is, and this is why I think a lot of teachers aren't terribly bright, and I include myself in that. So I'm okay. I think you can insult yourself within a group as long as you belong to that group. I think that's the rule of thumb these days. So, so if you think about a teacher who gives a multiple choice test and says, you got 50% on this test, you just passed. You just passed it. Do you think that really is a pass? Because what if you guessed and you knew some of it, but you kind of guessed on parts of it? So anyway, so this last little bit of the course is looking at probability of things, not just multiple choice tests and stuff. But I like to bring that up for you guys, because for the next 3 years, you're going to be writing tests, and many of those tests will be multiple choice tests. And some students, even by grade 12, they leave them blank if they don't know. And that is not a smart thing. Okay, it doesn't mean you're not smart. It just means that is not a smart thing to do. You should always guess. You should always try, right? And once again, I think teachers sometimes give multiple choice tests to help students, because it helps boost the marks up, but it doesn't always show what students truly understand about the subject area. But it is sometimes convenient. It's sometimes useful to do that. So anyway, so I'm going to show you some stuff on probability and the chance of something occurring. And so we're gonna do a little bit on that today, and hopefully it's kind of a nice way to end off the course. It's not a lot of heavy math. There's no solving equations and stuff like that, but it might surprise you, some of the results we get, and that maybe you never thought of that. Some things you might go, oh, I totally thought that's the way it was going to be, sort of thing. But here we go. Let's share our video here on that. So we're gonna, oops, I need to go back here. So I need to go to sharing. The Beavers motto. Okay, so here we go. Let's switch over. We're going to switch to Math 9. And I need a new unit. Actually, let's keep it within scientific notation unit here. There we go. Let's go to this one, and we'll just call this probability. Okay, and let's turn me off here because I'm going to turn the screen a bit, and hopefully I don't lose you guys in this process. My computer keeps dropping me something for some reason. I'm not sure why that is. Okay, so let's take a look at a really simple question first. I think a really simple question. I hope a really simple question. Dealing with probability. Okay, so let's say you flip a coin. And it's not a trick coin. We're going to assume all the things we're asking here are reasonable things you would find around the house. You flip a coin, and the question is, what is the probability of getting tails on the coin? So you got this coin, and there's a tail. Just kidding. There's like heads and tails. You know what I mean, right? So coin has two sides to it. So you call heads or tails, or whatever country you're from, you might have a different name for the both sides of the coin. But the idea is you're gonna get something from the coin that could happen here. Okay. Now, if you flip a coin fairly, and you let it land or you capture it, generally what we're assuming is the angular rotation of the coin, so that it's spinning through the air. It actually prevents it from landing on its end like that. So that's not something that happens unless the ground is really uneven, or you drop the coin in such a way that might happen. But if you truly flip a coin, it's not going to land like that, stay like that. It might bounce off its edge, but eventually it falls one way or it falls the other way, and it kind of makes that noise coins are famous making. So, for example, I just have a coin right now. You flip it. I'm gonna flip it now. You hear that beautiful sound? So that was a toonie that shows me a polar bear, and I'm going to call that my tail side. And on the other side is Elizabeth II, and 1996, so she looks a bit younger there. And yeah, so that's going to be my tail side of the coin. Okay, so really the chance of getting a tails, well, I think most of us would agree it's a 50% chance, right? So we'd say it's 50%. And now as a decimal number, 50% is 0.5. And many of the time, things we write in probability, we write it in decimal format. We'll say it's a 0.5 chance of occurring. So 0.5 means 50%, or sometimes we'll write it as a fraction. We'll say 50%, well, that's really 5 out of 10, but really that reduces down to 1/2. And so we might write this symbol. I'm going to write this symbol as I'm going to use the letter P for probability. So instead of writing out the word probability every single time, I'm going to write P. And then in brackets, I'm going to write down what it is I'm looking for. So let's say the probability of getting tails. Okay. So that way I've written that P bracket tails means probability of getting tails. And so that would equal 1/2. Okay. So I think we're all pretty good with that. If let's say you took a normal dice, not the one I showed you on the video, but your typical dice, cubic dice here. It's obviously got numbers on it, 1, 2, 3. And let's say you're wanting to know, if you roll this dice, the probability of getting a 3. So you want to know what's the chance or the probability of you getting a 3 on that dice. And let's write it as a fraction. Okay, so I think I want to sort of explain the definition of probability using ratios. So we've actually worked a lot with ratios in the last chapter, the idea of fractions. So I think we would have to know on a dice, if you'd have to kind of have a sense of what a 6-sided dice looks like. And of course, me saying a 6-sided dice kind of gives it away that it is a 6-sided dice, right? So a 6-sided dice is actually a 6-sided dice, right? Okay. So how many faces on a 6-sided dice? Well, on a 6-sided dice, there would be 7 faces. I mean, 8. No, 6. That's why they call it 6, right? So 6-sided dice would have 6 faces. And how many 3s are on that dice? Where am I here? All over the place. Well, there we go. How many 3s? Doot, just 1, 3. So the chance of getting that would be 1 out of 6. You could convert that to a percent if you wanted to, but let's just keep it as 1/6. So is it more likely or less likely to get tails on a coin or a 3 on a 6-sided dice? So we can, once again, I think these numbers are fairly easy for us to work in our heads, but sometimes if it's hard, what you might want to do is convert numbers to have the same denominator so that you can actually compare them to each other. But I think most of you guys could easily compare those two numbers. But let's say you turned a half into something out of 6. Well, you would have had to times the bottom by 3, which means you times the top by 3, which gives you 3 out of 6. So 3 out of 6 is a bigger number, of course, than 1 out of 6. So obviously getting a tails is much more likely, or say not much more, but it's more likely than getting a 3 on a 6-sided dice. So once again, I think most of you guys could see that, but if you get fractions that are confusing, you might want to convert to the same denominator, and that helps you truly compare the two numbers together. Okay, so let's try one more probability here, and I'm going to get you to do some fun stuff on the calculator that I'm not going to hold you accountable for, but it's kind of a neat little button that you might want to try out here, okay? And I'm not going to explain how this works right now because I think that might be a bit beyond the scope of the course, but it gets you kind of using your calculator in ways you've never tried before. So let's take a look at cards, okay? So cards, okay? And let's say that you are playing with a normal deck of cards. That's 52 cards in a deck. Okay, so normal deck comes with 52 cards, assuming you take all the jokers out and instructional cards. And let's just give you the question we asked before, the probability of getting the Queen of Hearts. Okay, so probably getting Queen of Hearts. Okay, well, you have to know how many hearts, how many Queen of Hearts there are in a deck of cards, I guess. And once again, that might not be something everybody knows. I mean, if you've never played card games before, then this question would be very challenging to do that. But there is only one Queen of Hearts. The same way there's only 1 3 on a dice, and the same way there's only 1 tail on a coin. So we say there's one chance out of all the things that could happen, okay? So if you were to pick a card from a random deck of cards, well, assuming it's random, you could have picked any one of the 52 cards. The same way you could have rolled any one of the 6-sided shapes on the dice, or any way you could have flipped the 2 different sides on a coin. So with a deck of cards, there's 52 cards. So it'd be 1 out of 52. Now I'm going to convert this to a decimal for you just to show you what that would be. So the chance of that is 0.02 approximately, which is about it's about 2%. So there's about a 2% chance of that happening. So for someone to draw the Queen of Hearts out from a deck of cards, there's about a 2% chance of doing that. But of course, there's about a 2% chance of them drawing any card out from the deck of cards, right? Like you said, what's the chance of you getting a 3 of spades? It's still 2%. So that's important. So what I wanted to do today, and just end it off here today, I'm going to give you one little question to think about, is let's just sort of look at the definition of probability. So I'm going to say the probability of A occurring. So A is something you want to happen. So for example, the Queen of Hearts, getting a 3, flipping a tails, okay? So the A really here is the thing you want to have happen. So we call that the event. So the event you want to occur. And we're going to start off with this basic definition of the probability of A. We're going to say that the chance of that occurring is what we call favorable events. Now, what is an event again? Well, that's the thing you want to happen, right? So favorable events would be in the question before, the Queen of Hearts. That would be favorable. Getting a 3 on the 6-sided dice, that would be a favorable event. That's what you want to happen. Or in the very first question, flipping a tails on a coin, that would be a favorable event. And then we're going to divide that by the total number of events possible. And that includes favorable and unfavorable. So in a deck of cards, because there's 52 cards, there's 52 things that could happen if you chose just one card. So that's where we get that from. Okay. So what I'm going to look at now is one more question, and let's take the probability of guessing a multiple choice question correct. Okay. And we're going to assume like the test is like this. One, there's A, blah, 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 B, blah, 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 C, blah, 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 and D, blah, blah, blah. And that's the question, and those are the answers there. Okay. And so your chances, what's the chance of you guessing a multiple choice question correct? That means getting it correct. And we'll assume that the answer stems, there is only one right answer. Your teacher's not trying to trick you or something. Okay. So I'd like you to write down that. Then what's the chance, the probability? I'm going to write you 2 more questions here, okay? So 1, 2. Now these next 2 questions are going to be, I think the first question is pretty easy, but the next 2 questions might be tricky for you. But I want you just to think about it. It's more to the thinking I want you to analyze here. What's the probability that's, let's say you had 2 such questions. So it was a 2-question test. And each question had these 4 answers here, A, B, C, D, A, B, C, D. What's the probability that you, knowing nothing, that you guess, so once again, guessing means you don't know the answer, you guess both correct? Okay. And then the last question I'm going to ask you, which I think is probably maybe a question you should ask yourself when you leave something blank like this. Let's say you didn't answer them, so obviously you got 0. But what's the chance that if you guessed, you get both wrong? Okay. Now, as I said, the bottom 2 questions, 2 and 3, they actually are tricky, and you may not be sure how to answer them. That's fine. But I want you to think about it, because this is what probability is about really analyzing the scenario and thinking about what could happen. What's the things that could happen here? But I think I'm hoping the first question, I think that's fairly straightforward if you understood the first part of the video. And I'll put another one out tomorrow, being a bit more specific with some of the probability things, looking at what we call tree diagrams and Venn diagrams. Maybe we'll see where we get to. I don't want to do too much on this near the end of the course. So anyways, hope you guys are doing well, and I will send that to you right now.